Section 1.2, Properties of Real Numbers. Our objective here today is to graph and order real numbers and to identify properties of real numbers. If you don't remember all of the different types of numbers, you might want to write these down. You can't necessarily use them on a test, but just to look back and use them on quizzes or daily assignments would be great. The first set is the natural numbers. These are the counting numbers like 1, 2, 3, 4, 5, 6, and so on. The natural numbers do not include fractions. They don't include negative numbers. They don't include the number 0. So it's just the actual counting numbers. Whole numbers are all of those natural numbers that we just talked about, plus the number 0. So whole numbers start with 0, 1, 2, 3. I remember this one because the whole number, the word, has an O in it, which is the one that includes the 0. Integers are the natural numbers and their opposites. So the natural numbers are the counting numbers. Opposites mean opposite sign. So it's all of those numbers that we had, and they're negative. So -1, -2, -3, and so on. And 0 is included in the integers as well. Rational numbers are all numbers that you can write as a fraction of two integers. In the book, they call it a quotient of two integers. So quotient is divide. Divide means fraction. These numbers don't have to look like a fraction. For instance, the number 2. It doesn't look like a fraction, but we could write it as the number 4 over 2, or 6 divided by 3, or something like that. So it doesn't have to necessarily look like a fraction to be a rational number. You just have to be able to write it as one. This does include the terminating decimals. For instance, 1/8 is 0.125. Terminating means stops. It could be a long number and stop or whatever. It also includes the repeating decimals, which are indicative of this bar that you write over it. So if you have 1/3 and the number doesn't stop, or it goes all the way across your calculator screen, it's probably a repeating decimal, and then you put the bar over that one. Irrational numbers have a decimal representation that neither terminate or repeat. So terminate has an end, but these keep going, but they don't repeat. These numbers cannot be written as quotients of integers. So irrational numbers are all the square roots. When you look at, for instance, the square root of 4, though, even though it looks like a square root, it's not an irrational number because it stops. Okay, so this keeps going. Okay, so neither terminates means keeps going. So the square root of 4, even though it looks like a square root number, since it simplifies down into a whole number, this would actually belong in the group above it, which is the irrational numbers. Problem number 1, your school is sponsoring a charity race. Which set of numbers does not contain the number of people P who participate in the race? Natural numbers, integers, rational numbers, or irrational numbers? Okay, so since this one talks about the number of people, that means these are probably going to be counting numbers. It could be the positive integers. It could also be the rational numbers, because we could write the number of people as a fraction of two numbers. This one that do not pertain to this one would be the irrational numbers, because anytime you're talking about a person, it's not going to be a decimal. So I would say irrational numbers are the ones that don't work. You can pause here and work on Got It question number 1 if you'd like. If each participant made a donation D of $15.50 to a local charity, which subset of real numbers best describes the amount of money raised? So on this one, let's go through each of these sets. We have the natural numbers, we have the whole numbers, we have the integers, we have the rationals, and we have the irrationals. So let's just go through them one at a time. So $15.50 can't be a natural number because it's not a counting number. It can't be a whole number because, again, it's got some decimal in there. Integers are just the numbers and they're opposites, so it can't be that one. So basically we have to decide, is this one a rational number or an irrational number? So since this is a decimal that stops, or you could put the 0 on there and it stops, it has to be a rational number. Problem number 2, what's the graph of the numbers -5/2, the square root of 2, and then 2.6 repeating? So I find it easier if we change each of these to their corresponding decimals to graph them a little bit closer. So -5/2, if you divide those two, you get -2.5. And -2.5 is between -2 and -3. The square root of 2 is about 1.41 or 1.4. And then, of course, this is your 2.6 repeating. So 1.4 is about right here. And then your 2.6 would be a little bit over half, goes right here. So this one belongs to 2.6 with a bar. This one belongs to the square root of 2. And this one belongs to -5/2. So easiest way to do this is to just use a calculator, get their decimals, and put them on that way. If there are a couple close together, make sure you represent which one they belong to. Here's got it question number 2. You can pause and try this one on your own just to see if you get this one right. What is the graph of the numbers? So 1/3 I already know is about 0.3 repeating. -1.4 is already there. And then the square root of 3, is about 1.7, and I'm just estimating that to 1 decimal place. So now we'll estimate where they are on the graph. This one belongs to the square root of 3. -1.4 is on the negative side. It's between -1 and -2, just a little under half. And then 1/3 is about 0.3. And that's what that one looks like. Number lines help to order groups of numbers, and inequalities are used to show or compare using less than or greater than. So how do we compare the square root of 17 and 3.8? When you're looking at this one, when you look at this one, you'll notice that in the book, they're comparing these to the square root of 16. What they're using is all of the perfect squares, like 2 squared is 4, so square root of 4 is 2. They'll go square root of 9, square root of 16. Each of those lists of perfect squares, they compare it to those. I would rather just say, what is square root of 17? So I'm going to go on my calculator. Square root of 17 is about 4.12. So the square root of 17 is greater than 3.8. Okay, so the symbol we would be looking for would be this one. Got it, question number 3. You can pause, try it yourself, and check it out. So square root of 26 is about 5.1, which is less than 6.25. So the square root of 26 is less than 6.25. They would compare this one to the square root of 25, which is 5. But again, just go directly to your calculator. One property of real numbers excludes a single number 0. 0 is the additive identity for the real numbers. 0 is the one real number that has no multiplicative inverse. Opposites or additive inverses of any number A is negative A. So when they talk opposites, it's opposite sign. Additive identity, the sum of a number and its opposite is 0. So the additive identity of 1 would be negative 1 because when you add them together, you get 0. A reciprocal or multiplicative inverse of any non-zero number A is 1 over A. And those, when you multiply the two, you get 1. The product of a number and its reciprocal is 1. This is called a multiplicative identity. And then we go through some properties of real numbers. You'll probably want to write these down somewhere, especially if you have to come up with which step you're talking about. So the first property is closure. Closure under addition. A plus B is a real number. It also is closed under multiplication. A times B is a real number as well. Commutative properties. Basically, when you look at the members on the left side, the members on the right side are reversed. So reverse order, and it doesn't matter if you're adding or if you're multiplying. Notice for multiplying, A times B is the same as B times A. Associative properties. Notice on the left side you have A plus B in parentheses. On the right side you have B plus C. Notice that the members are in the same order, where the parentheses is what changes. So it doesn't matter if you're adding anything together. If there's 2 in parentheses, you still get the same thing out. Multiplication works the same. Multiplication is associative. If you multiply A times B together and then times C, you get the same answer as when you multiply B times C together and then multiply by A. The identity for addition is 0. The identity for multiplication is 1. It just means if you add 0 to anything, you get that member. Or if you multiply any member times 1, you get that member. An inverse, the additive inverse, is when you add the opposite and get 0. The multiplicative inverse is when you multiply by it and get 1. Distributive property doesn't have anything to do with addition or multiplication. It kind of combines the two. Basically, you're taking each member that's on the outside times the member that's on the inside, and the sign that you use is the same as the one in the middle. So you get A times B on the right plus A times C as well. So the first few questions are going to be asking, which property does the equation illustrate? So when you look at this one, obviously it's multiplication. So first decide, is it multiplying or adding? This one is multiplying because anytime there's no item in the middle, it's multiply. So this is multiplication. And when you look at it, if you take negative 2/3 times negative 3/2 and get 1, it must be the multiplicative inverse. Or you could say inverse of multiplication. The next one, B, notice how there's parentheses. This one has 3 times 4 in parentheses times 5. And what they did was they reversed just these two. So when you're looking at that one, commutative property. And this one is multiplication. So we're going to do commutative property of multiplication. Got it? Question number 4. You can pause and then jump back in to see if you got it right. Which property does the equation illustrate? Notice right here, this part turns into that part. The 2g remains the same. So how do they go from here to there? They multiplied 3 times g, they multiplied 3 times h, and that is the distributive property. Distributive property doesn't have multiplication or addition, so you just leave it just like that. The others up here, you have to have what does it belong to, multiplication or addition, and then what property does it go with. Please review and practice. Bring questions for tomorrow.